Jai Hind to all. My name is Vaishali Deshwal, and currently I'm working as an assistant professor at AKGEC, Ghaziabad. So this is the continuation of the previous session, and in the previous session we have discussed PDS, that is Public Distribution System, and Social Welfare System. We were basically discussing the role of blockchain in PDS and other social welfare systems of government. So we are left with these two topics. The first one is the blockchain cryptography, and second is the privacy and security on blockchain. So we have already discussed some part of the blockchain cryptography, that what is the cryptography, what are some of the key concepts in cryptography, for example, private key, public key, and encryption and decryption. So all these we have covered. And the next thing we were discussing, this hash function. So what is the importance or the why the hash function is indispensable in blockchain? So one of the most notable uses of the cryptography is the hashing, that is the cryptographic hashing. So it enables the immutability, that whatever data you are storing, that cannot be changed. So it enables the immutability in the blockchain, and encryption in the hashing does not involve any kind of the keys. So when a transaction is verified, then this hash algorithm adds a hash to the block, and this is how the blocks they are formed. They are attached to each other to form the blockchain. So add the hash to the block, and a new unique hash is added to the block from the original transaction. So this concept, the forming of the blocks or how they are attached to one another, we have already discussed in the unit 1. Then hashing continues to combine or make the new hashes, but the original footprint is still accessible, and the combined hash is known as root hash. So such kind of the functions, they help in linking the blocks as well as maintaining the integrity of data inside the block, whatever data or whatever information you're storing in the block. And any changes in the block data, it will lead to the break of the blockchain. As example, you can mention this MD5 stands for Message Digest 5, and SHA stands for Secure Hash Algorithms. Under these are the commonly used hash functions. Now these are some of the properties of the cryptographic hash and some of the benefits of these functions in blockchain. So what are the properties? So whenever you are using the hash function, it doesn't change for any particular message. Secondly, every minor change in data, it will result in a major change in the hash value. And third is the input value cannot be guessed from the output hash function. If you know the hash function, then you cannot assume or cannot derive the input value. So these hash functions, they are quite efficient, fast, as they largely rely on the bitwise operations. Now, what are the benefits? Benefit is that they reduce the bandwidth of the transactions, prevent the modification in the data block, or as we have mentioned that it is providing the immutability, and then make verification of the transaction easier or faster, we can say. Now the use of cryptographic hash function, that where we use such kind of the functions. So as blockchain is public to everyone, it is important to secure data in the blockchain, whatever the information or whatever details you are storing. So it's quite important to store that, to secure that, and keep the data safe from the malicious hands, which can be achieved through this terminology or technology named cryptography. So when the transaction is verified through the hash algorithm, then that transaction becomes eligible to be added into the blockchain. And as the transactions become confirmed, then it is added to the network and making the chain of the block. And this is how the blocks are linked to form the blockchain. Now, cryptography, it uses some codes, and we call these mathematical codes. Such codes, they ensures the users to whom the data is intended, and that can be obtained for reading and processing the transactions. Then many new tools related to the applications of cryptography in blockchain have emerged over the years with the diverse functionalities. What are the benefits we can count of the cryptography in blockchain? We are discussing the role of cryptography, or how we are using, how we can embedding this concept in the blockchain. So what are some of the benefits of using the cryptography in blockchain? So first is, there can be number of the benefits, and some are listed as here. First is the encryption. So encryption is the cryptography, it uses the asymmetric encryption. We have already studied the asymmetric encryption. In asymmetric, we are using two different type of the keys, the private key and the public key. Means we are using different keys for the encryption and for the decryption purpose, to ensure that the transaction on the network, it will guard the information and the communication against unauthorized revelation or access to the information. Second is the alteration, or you can say immutability. So it is a core feature of the blockchain, or the cryptography, you can say. So this feature, it will make it sure that the alteration will not be easy. So it makes it possible for the blocks to get securely linked by the other blocks, and also to ensure the reliability of data, whatever you are storing in the blockchain. So it also ensures that no attacker can derive the valid signature or the details for unposed queries for the previous one. Third benefit is the security. So it will make the records of the transaction easier using some encryption of the data and assessing of the data using the keys. So the hashing tampering with data is not possible, and thus it makes the blockchain more secure. Fourth is the scalability. Scalability means that cryptography makes the transactions irreversible, and this thing, it will give the assurance that all the users, they can rely on the accuracy of the digital ledger. So it allows the limitless transactions to be recorded in the network, and that is why we are saying that it helps in the scalability. Now we have discussed the benefits. We now will discuss the limitations, or what are some demerits of the cryptography in blockchain. So first demerit is the information is difficult to assess. Now, strongly encrypted and the digitally signed information, it can be difficult to access even for the legitimate user. So that is the drawback at some critical time of a point. And the network can be attacked and rendered the non-functional by an intruder. So this is one of the drawback. Then second is the high availability. It is also one of the limitation, fundamental aspect of the information security also. It cannot be ensured through the use of the cryptography. So for this, we can use some other methods are needed to guard against the threats, such as the denial of the service or complete breakdown of the information systems. Third limitation is no protection against the vulnerabilities. So cryptography doesn't guard against the vulnerabilities or the threats that emerge from the poor design of the protocols or the procedures or systems. So such kind of the issues, they need to be fixed with the proper design of the defense infrastructures. Okay. Next limitation is that it is quite expensive. Cryptography needs money investments and huge time, and public key cryptography needs setting up and maintenance of public key infrastructure, which requires high investments. Addition of the cryptographic techniques while sending messages and the information processing, it adds delay also. So it is expensive and it make the process delayed. Next is the vulnerability, that the security of this thing, it will depend on difficulty of the mathematical problem and the complexity. And any breakthrough in solving such kind of the problems, in mathematical problems, whatever you are taking, it can make the cryptographic technique vulnerable. Next topic is the privacy concerns in blockchain. So if you see this syllabus, then in unit 5th there are two things. This is the last topic of unit 5, privacy concern in blockchain and the security challenges in the blockchain. So what are the previous privacy concerns in the blockchain? So first is the pseudonymity. So while blockchain transactions are pseudonymous, meaning they are linked to the digital address rather than the real world entities, they are not entirely anonymous. So this is one of the concern. Analytical tools and the techniques, they can often de-anonymize the users, and which raise the privacy concerns. Next is the data leakage. So in data leakage, blockchain transparency, a feature which is praised for its ability to prevent the frauds, it can also lead to the leak sensitive information. Confidential data, once recorded on the blockchain, becomes immutable, means it can be changed, it can be altered, which enables that the data, whatever you have stored, visible to all the participant. And this is what we are referring the data leakage. Next, or the last topic of unit 5 is the security challenges in the blockchain. So there are many challenges in blockchain, security challenges especially. First is the 51% attacks. So there are many 51% attack is there, then smart contract vulnerabilities, then Sybil attack, endpoint vulnerabilities, and phishing attacks. So let's understand these challenges one by one. So first is 51% attack. Why we are referring it as 51% attack? It is one of the most well-known security threat in blockchain, and we are referring it as 51% attack. So in blockchain network, the transactions are validated by, they are validated by miners. And who are the miners? Miners who solve the complex mathematical puzzles. So if a single entity or the coalition of the miners control over 50% of the network computing power, they could easily manipulate the blockchain and reversing the transactions and double spending cryptography. They will make the attack possible, and that is why when the control is over 50%, then the attack can possible, and thus we are referring 51% attack. Next is the security, next is the smart contract vulnerabilities. So we have already discussed this term smart contract many times. So smart contracts are the codes, so and they are vulnerable. So smart contracts are executing contracts with the terms of agreement directly written on the code, and they are the whole mark, or you can say they are the core concept on which the blockchain rely, and many participants participate in the network because there are some set of rules or some codes, and one part is the smart contract which is regulating all these things. So smart contracts are the self-executing contracts with the terms of agreement directly written on the codes, and they are the hallmark. So they are not immune to the vulnerabilities, Bugs and the vulnerabilities in these codes can lead to the significant financial losses and security breaches also. Next attack is the Sybil attack. So next attack is a Sybil attack. In Sybil attack, hackers generate various fake network nodes, and using those nodes, the hacker will acquire majority consensus. Consensus is the meeting point that where all the parties agree. So acquire the majority consensus and disrupt the chain's transactions. As a result, a large-scale Sybil assault is nothing quite a 51% attack. Then third attack is the endpoint vulnerabilities. Endpoint vulnerabilities are the vulnerabilities of the blockchain endpoint is another important security concern in blockchain security. And the blockchain network's end is wherever user acts with the blockchain. Means you are in such kind of the vulnerabilities, you need to identify the end. So the end is wherever the user act with the blockchain is the end on the electronic devices, like on the computers or the mobile phones. And the hacker will observe the user behavior and target these devices to steal the user's key or the information. And this might be one of the foremost visible blockchain security problem, the endpoint vulnerabilities. Okay, the next attack is the phishing attack. So phishing attack is the phishing attacks are the hacker's goal in a very phishing attack means is to steal the user's credentials, and they'll send the legitimate looking emails to the owner of the wallet key, and then user is required to enter the login credentials via that fake hyperlink. So this is what we are referring as the phishing attacks. So having access to a user's credentials and other sensitive information, it will lead to the damages for both the user and the blockchain network, and they are liable to the follow-up attacks. So phishing attacks, they lead to the follow-up attacks. Next is the routing attacks. Routing attacks. In routing attacks, the hackers can use the account's anonymity to intercept data. So a blockchain network and the application rely on the real-time movement of massive amount of knowledge, and hackers can use the account anonymity to intercept data because it's being transmitted to internet service providers. Next is the scalability issue. Scalability issue is that the blockchain technology continues to be in its infancy. So it has some scalability problems. This implies that the network will solely handle a restricted variety of the transactions at any point of time. There are offline solutions also. There are multiple offline solutions and the side chains which you can use to avoid the scalability issues. So side chains we have discussed in unit 2 or unit 3 might be. Okay. The last attack is last type of the security concern is the malicious node, and as the name suggests itself that some of the nodes are malicious. So if some of the participants which are involving in the blockchain network are malicious, then you can say or you can refer it as a malicious node. So the other security problem facing blockchain technology are the danger of the malicious nodes, and this will happen once a lousy actor, it will join the network. So tries to disrupt it, and these lousy actors, they'll try they try to attack the network by flooding the network with the transactions or making an attack to reverse the transaction process. So we have covered the cryptography concept, that what is cryptography. In the previous lecture we have discussed the cryptography, types of cryptography, asymmetric and the symmetric cryptography, some of the terminologies which are involved in this concept, encryption, decryption, private key, public key, then the types we have seen. and then what is the role of hashing or the use of hashing in the blockchain. And the last topic of Unit 5 is the privacy and the security challenges in blockchain. So in privacy concern, we have seen the anonymity problem and the data leakage problem. And security challenges, we have discussed the several attacks, 51% attacks, then smart contract vulnerabilities, endpoint vulnerabilities, Sybil attack is there, phishing attack, and scalability issues or the challenges are there, then routing attacks and malicious node. So I think this is the good point to stop here. Thank you.